Hey guys, I just wanted to do a little video lecture on some of the stuff that you've been reading about in the textbook. First of all, I want to talk about kinetic molecular theory, KMT. First of all, let's break that down. Kinetic is a type of energy, right? Kinetic energy is the energy of motion. Molecular means molecules, right? And then theory, obviously, you know what theory means. So this is all about the energy of molecules. This particularly applies to gases. And you'll notice that this whole chapter that you were assigned for your AMI reading is all about gases. And really it comes down to the proponents of kinetic molecular theory, okay? Now there are several different assumptions in kinetic molecular theory. I'm gonna list them here in no particular order, okay? My number one is that gases are composed of small, hard spheres with approximately zero volume. What that means is they are super tiny little specks that have such small, take up such small amount of space, we say that they take up none, okay? So basically they're little dots floating around. The second is they are in constant, rapid, random motion. So those little dots are constantly zing-zanging all over the place, okay? There is no predictability to their movement. They never slow down. They never stop. They just keep ping-ponging all over the place, okay? The third is that each collision is elastic. So what does that mean? Okay, picture a DVD player screen. And you know how the logo bounces around and you're always wanting it to hit the corner of the screen, right? That's the goal of that. When you're watching that, you're like, just hit the corner, just hit the corner. And every once in a while it does. And you're like, yay, okay. Every time the DVD symbol bounces off a corner of your television screen, does it ever slow down? No, it does not, right? It continues with the same trajectory that it came in at. That means that when it hits the corner of the screen, no energy is lost in that collision with the edge, right? So what we're assuming is when a gas particle, let's stop talking about the DVD screensaver for a second. When a gas particle hits the side of its container, no energy is lost. When a gas particle collides with another gas particle, no energy is lost. And that's what an elastic collision means. It means that it hits it and bounces back off with absolutely no change in energy. Okay, what else do we got here? Let's see. 4. Temperature and kinetic energy are directly related. I'm going to put equal direct relationship. And what these assumptions, what they help us to understand is how gases act. In a perfect world, how do they behave? Well, they're tiny little particles that bounce around whatever space that they are given. There's no pattern to their movement. When they hit the sides of the container or they hit each other, they don't lose energy, and their temperature and their speed and kinetic energy are all interrelated, okay? Those are the main proponents of kinetic molecular theory, and they help us to think about how gases behave. You have to understand kinetic molecular theory before you can piece apart the other gas laws.